These are problems relating to reading graphs for inequalities. So if you could turn your class notes packet now to page 17. And I'm going to do two examples and then have you try two examples and then check with me. So in problem number 9, the two graphs of y1 and y2 are given. And so we know that y1 is a parabola and y2 is a line, but specifically you don't need to know what they are. So I just highlighted the one graph in blue. So the y1 I put in blue, and then the y2 I put in pink. And you need to find the critical numbers. So the critical numbers are wherever the two graphs are intersecting. So it's actually helpful to use a straight edge on this. So if I take my ruler and just line it up, and you can see on the left side, it's intersecting at a -2. On the right side, it's intersecting at a +2. So those are my two critical numbers. So I put up my critical numbers are x is equal to -2 and a +2. And then I'm going to just do a number line like we did for the algebraic types of problems. And so I have a -2 and a +2. And then I'm just going to be using T for true and F for false. And so the question I'm going to be asking myself is, where is y1? Where is the blue greater than y2? So where is the blue above the pink? Where's the blue above the pink? Okay, so I'll just use my straight edge, or you could just even use your pencil if you want. And I'm just going to look at that particular region. So in this region, even though I don't see the blue, I know that it's going infinitely in that direction. So in that particular region, I can see that the blue is above the pink. So from -infinity going all the way to a -2, so that would be a true statement. And then from a -2 going through +2, that would be false because the pink is on top of the blue. And then from +2 out to infinity, it's going to be again a true statement. Okay, so I've represented that by just writing true in this region, false in this interval, and true in this interval. And so the true part, I'll just highlight it, right? And then since it says just greater than, I'm going to use parentheses. So my solution on this is -infinity to -2, and it's parentheses, union 2 out to infinity. Okay, let's try another example. So for the next one, in problem number 10, we're looking at where is y1 less than or equal to y2. So I highlighted the y1 in pink, and then I put the y2 in blue. And first of all, I'm going to find the intersection. So those are the critical numbers. So if I line up my straight edge where the intersection is, the x value to the left side is a -5, and then to the right side it's a +4. Okay, so I wrote that up on top. Critical numbers are at x equals -5 and 4. And then I set up my number line, -5 to 4, and then I'm going to test my interval. So in this one, I want to know where is the pink graph below the blue graph. Where is the pink below the blue? So it'll be helpful to color code this. So when I look in this region here, I can see that the pink is above, so that would be a false statement. And then looking at it in this particular region, from here to here, that would be a true statement. And then from 4 to infinity, that would be a false statement. So then it goes false, true, false. So it's just going to be this middle region. And since it says equal to, I'm also going to be including those. So my solution is a -5 to 4. Okay, please pause the video, and I'd like you to try problems 11 and 12, and then come back and check your answers. Okay, here are the answers to 11 and 12. So in 11, I actually changed the problem and I wrote it as equal to, just because I think it's more interesting with equal to in this problem. So here I have the blue is this graph, and then the pink is the line, and then I just intersected them. So my critical numbers are at -1, 1, and 3. And then I do my test numbers and I determine that it's false, true, false, true. So my solution is -1 to 1, bracket, bracket, and then 3 out to infinity. Okay, so if you did it with just less than, then this would be parentheses, 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 and parentheses. For problem number 12, my critical numbers are at -4, -2, and 1. And then here's my test number line, and it is false in this interval, true, false, true. So my solution is a -4 to -2 bracket, and then union, bracket, 1 out to infinity. Okay, if you could turn to the last page, and we're going to look at the final thing for this section, which is on finding domains. It says to find the domain for each function and then express your answer using interval notations. So the two main thing that you're looking for, or the main thing that you're looking for when you are asked about domain is the question, are there any restrictions on x? That's really the same question. So the two things that you want to be careful with is that x cannot be undefined, meaning that you can't have 0 in the denominator. And the second thing is that you can't have a negative number under a radical. Okay, so these are basically no good. You have undefined and the square root of a negative number. So besides these two things, if your function has x's, it can be any number that it wants to be. Right? So if you keep that in mind, then these questions are easy to answer. Okay, so for the first one, you have a polynomial. Polynomials are very, very nice functions because there are no restrictions. You don't get any undefined because there's no denominator, and you don't have a radical, so you don't have to worry about negative numbers. So then it's just all real numbers, so it's -infinity to infinity. Okay, if you have, for problem number 2, you have a rational function, you have to be careful with anything that will make the denominator as 0. So x cannot equal 7, right? Numerator can equal 0, so the numerator will be fine. And so I'm just going to write it out as interval notation. It's -infinity to 7, and then union 7 out to infinity. Okay, for the third problem, this is a square root, so when you have square roots, you have to be careful that you don't get any negative numbers. So you're going to set up this inequality of the radicand. So the radicand is whatever is under the radical. This is the radicand. The radicand has to be greater than or equal to 0. So I take my radicand of 3x plus 1 and set it greater than or equal to 0. And this is a linear inequality, so I just solve it just like a linear equation. 3x greater than or equal to -1, x is greater than or equal to a -1/3, and then I'm just going to write it as an interval notation. So it's a -1/3 including it, and then out to infinity parentheses. Okay, for problem number 4, it's similar to problem number 3, except now the radicand is a polynomial. So you'll set your radicand greater than or equal to 0. So you get x squared minus 2x minus 15 is greater than or equal to 0. And then I'll factor that as x minus 5 and x plus 3 greater than or equal to 0. So it becomes a problem just like we did in the previous 2 pages. So my critical numbers are at a -3 and a 5. And then I set up my number line, do the test numbers. To the left of -3 is positive, positive, positive. Or I'm sorry, it's a negative, negative, which overall is a positive. Between -3 and 5, if I put in 0, it's a negative and a positive, so it's a negative. And then to the right of 5, it's going to be positive, positive, so it's a positive. So my solution would be -infinity to -3, bracket, union, bracket 5 to infinity. Okay, I'd like you to pause the video and try problems 5 and 6, and then come back and check your answers. Okay, for problem number 5, this is another square root. So I set up that the radicand has to be greater than or equal to 0. And so I have 7 minus x is over 3x minus 2 is greater than or equal to 0. So my critical numbers are at x equals 7 and at 2/3. So I set up my number line and I get negative, positive, negative. I know that 2/3 cannot be a solution, even though it says equal to, because that will make the denominator a 0. So my solution would be 2/3 to 7, parentheses on the left side and a bracket on the right side. In the last problem, I'm going to factor out the denominator. So that'll be x times x minus 3. And so if I set that greater than or equal to 0, so that's the radicand being greater than or equal to 0, my critical numbers are at x equals -1, 0, 3. I set up my number line, and I get a negative, positive, negative, positive. And at 0 and at 3, they are vertical asymptotes. So then my answer solution would be -1 to 0, including -1, not including 0, and then 3 out to infinity.